Welcome back, chemistry students. Today we're going to move into part 2 of solutions. So make sure you have your spiral notebook out, take some really good notes, and let's get started. So we're on solutions part 2, and our objective is for you to be able to describe how dissolving works and the factors that affect the dissolving rate. After you do this lesson, there's a supplemental video and an assignment for you to complete. So let's work on solutions. Let's remember and review the 3 types of solutions. The first type of solution is the unsaturated solution. This is a solution that is able to dissolve more solute at the given temperature. It still has room to dissolve more solute. You then have the saturated solute, the saturated solution that contains all of the solute that it can hold at the given temperature. It can't take any more unless you increase the temperature. And then we have the supersaturated solution, and this contains more solute than it can hold at the given temperature. You've put in so much that it has no more solution to dissolve more solute. And that becomes a fairly unstable solution. So the 3 types of solutions: unsaturated, has room for more; saturated, holds it all; supersaturated, has taken in too much. Now let's talk about how dissolving actually works. And we're going to work using here with the water molecule. And if you look at the top right of your screen here, that's a familiar shape for you. You have the 2 hydrogen atoms and the 1 oxygen atom. And when this water molecule exists, it has a slightly negative charge on the oxygen side and a slightly positive charge on the hydrogen side. And so not all types of matter dissolve easily, but water is an excellent solvent due to it being a polar molecule. And polar means that it's oppositely charged at its ends. And we just looked at that. The oxygen side of the molecule is slightly negative. The hydrogen side of the molecule is slightly positive. And if you remember how those water molecules stay together, the negative side of an oxygen, of the water molecule, is attracted to the slightly positive side of the hydrogen part of the molecule, and that's what forms that hydrogen bond. But water is an excellent solvent due to it being polar, and polar means oppositely charged ends. And although the overall charge of water is 0, it has that slightly negative and slightly positive side to it. Polar solutes, like ionic compounds, will dissolve well with water due to the attraction at the opposite charges. Let's look at that. So something like sodium chloride or salt will dissolve very well in water. Also, sugar will dissolve well in water. Now, dissociation is another vocabulary word for you, is the process in which ionic compounds, also known as salts and crystals, separate into ions, usually in a reversible manner. And when we get into chemical compounds a little bit later, this will be a little bit more clear for you when we start looking at the ionic and the covalent compounds. So in the ionic compound, the positive ends of water, of the H, attract to the negative ions of the salt. And the negative ends of the water attract to the positive ions of the salt. And this attractive force pulls the ions away from the crystal being the solute. These water molecules surround the ions, and they continue until all the ions are fully separated. We call that dissociation. And we're going to look at that in a visual in just a moment. Now, this supplemental video is also included in your Google Classroom tab, so you can go back and look at it again without having to scroll through the slides. But let's look at it here and watch what happens.
Sodium chloride crystals are held together by attractive forces between the positively charged sodium and negatively charged chloride ions. When a crystal of sodium chloride is placed into water, the hydrogen ends of polar water molecules attract the negatively charged chloride ions and gradually surround them. Likewise, the oxygen ends of water molecules are attracted to and surround the positively charged sodium ions. The hydrated ions drift away into the solution, allowing new water molecules to surround newly exposed ions. Gradually, the entire crystal dissociates into solution.
And so whenever you're dissolving salt in water, the process of dissociation is happening. And so there are some other factors that affect the rate of dissolving. One, of course, is smaller solute size. The smaller the solute, it increases the surface area so that the solvent has more places for contact. So imagine for a moment when you go to make a cup of tea. If you take a sugar cube and put it into the hot tea, you have to stir it around a lot for that sugar to dissolve. That's because it has 6 sides and there's still a lot of sugar all packed into it. But if you took a teaspoon of sugar and slowly added that solute in, it has all those very small particles and it gets a chance to dissolve a lot quicker. The other way you can affect the rate of dissolving is by heating the solvent. Increasing the temperature increases the kinetic energy of the particles. They start bouncing around more, and therefore there's more collisions, and that solute can dissolve. And of course, the third factor is stirring the solution. You can do that with a stirring rod, a spoon, a straw. If you stir the solution, it brings fresh solvent in contact with the undissolved solute. And so the 3 factors that affect the rate of dissolving: smaller solute size, heating the solvent, and stirring the solution. All right, let's do a quick review of solutions. Solution is a homogeneous mixture that has the same composition, color, density, and taste throughout. There are 2 parts to a solution: the solute, that's the substance that's being dissolved, and the solvent, which is the substance that's doing the dissolving. Solutions can be unsaturated, saturated, or supersaturated with solute. Multiple factors affect the rate and amount of solute that can be dissolved. The solute size, the smaller the solute size, the easier it is to dissolve. The warmer the temperature, the faster the solute will dissolve. Polar solutes dissolve best in water. Stirring the solution increases the dissolve rate. And water is our universal solvent. All right, that was a short session, but I'd like you to go back and look at your notes from yesterday, part 1, and today, part 2, and then complete the assignment in the assignment tab. You guys have been great. We spent 2 days talking about solutions. We'll see you next time. You guys have a great day.